So, hello everyone. First of all, I would like to thank everyone for taking their time out from their busy schedule and joining this webinar. So today, here is Arif. He will be presenting the webinar on SAM2, the model from Facebook and its applications. So it's over to Arif Safi. Please go ahead.
Hello everyone and welcome to today's webinar on SAM2, a groundbreaking AI model designed for object segmentation and tracking in videos. So before going deep in this topic, I would like to share my screen to you. Is it visible?
Yeah, Arif, your screen is visible.
Okay. So I will be walking you through the feature and capabilities and the potential applications of SAM2. Whether you are in robotics, video editing, or autonomous vehicles, SAM2 has something for you. So first, we need to understand what is SAM2. Let's start with an overview. SAM2 is an advanced AI model that automates object tracking and masking in videos. You can simply click on an object and SAM2 will track it across the entire video, seamlessly handling complex movements and environment. Let me give you an example. Imagine you are editing a video where you need to track a moving car in an action sequence. Instead of manually adjusting the car position frame by frame, SAM2 will handle it for you. One click and it will follow the car throughout the video. So now question is arise, why we need SAM2 when SAM is already exist? So the major difference between SAM and SAM2 is like SAM2 is different from the original SAM. While SAM focused primarily on image based instance segmentation, SAM2 expand that functionality to videos. SAM2 was great. SAM was great at detecting segmenting object in a simple static image, but SAM2 can track object across the multiple frames, offering much robust video analysis. So let's say you are working with surveillance footage. With SAM2, you can select an object like a person, and the model will follow the person across the entire video, even when they move in or out of the frames. Now we will see how does SAM2 work. SAM2 work in three main steps. Input, it accept various visual input like video frames or even coordinates, click coordinates. And second step is segmentation. The model identify and segment individual objects even in cluster scenes. So segmentation means basically means masking the object. And third one is tracking. SAM2 can track these segmented objects across multiple frames using advanced techniques like optical frame. So we can take an example like in medical imaging, SAM2 can help segment and track a tumor in multiple MRI scans, allowing doctor to monitor its growth over time. So I would like to give the example of how does SAM2 work through a video. So for the demo purposes, I created a Streamlit application to see the working of SAM2. So here, first you need to upload a video and there will be first frame will be extracted from that video and you will need to select a object you want to track throughout the video. And it will give you one output video in which the selected object will be tracked throughout the video. Like in this video, you can see in the output video, we selected this object and it was tracked throughout the video, even in the crowded place. So next is how can we use SAM2 in real life applications? The real power of SAM2 lies in its wide range of applications. Let's go through a few examples. In robotics, SAM2 can help robots identify and manipulate objects in dynamic environment. In autonomous vehicle, SAM2 track other vehicles and obstacles for safer navigation. But it is not that much good in the real time. I will give you a example of that later in the webinar through a video also. And in video editing, s- SAM2 streamlines video post-production by allowing editors to apply effects or masks to object in motion. And as I give you an example of medical imaging, so it can assist in many things in medical. Like one more example, in video editing, imagine you are working on an advertisement where you need to follow a product as it moves across the screen. SAM2 will allow you to track that product seamlessly, reducing manual work. Now, the next thing is challenges in video segmentation. Of course, no model is without its challenge. Video segmentation comes with a set of hurdles, including handling multiple objects, especially when they are overlap or interact with each other. Keep tracking of object can temporarily disappear from the frame. Like if a object is disappear for some frames from the scene and it reappear in the scene. So in that case, might be SAM2 might be it cannot it can face obstacles to retract that object. Ensuring real-time performance, which is critical in applications like self-driving cars. Maintaining temporal consistency as lighting or camera angles change. If you are tracking multiple people in a crowded scene, SAM2 may struggle to differentiate between them when they are overlap. However, with careful tuning and additional input points, this can be improved. Now, we will see how we can track multiple objects. SAM2 use a point-based object selection mechanism. You simply click on an object and SAM2 generate a mask for that object and track it across frames. It also leverage optical flow and temporal attention to predict the movement of object across frames. So we can understand this by taking an example, like in a sport game, you can click on a player or you can click multiple players and SAM2 will allow that players across the entire match, automatically adjusting for changes in their position and movement. So I will show you another video where you will see SAM2 tracking multiple objects. Here you can see SAM2 is tracking the multiple object as well as the there are two-person in that video and a ball also. So it's tracking all things. For those of you who are developers or work in technical teams, integrating SAM2 into your project is straightforward. First, you need to clone the SAM2 repository from GitHub. And after that, you need to install dependencies, including PyTorch and Python. So when you are installing the dependency, you need uh, you need to keep this mind that you have to install Python 3.10 or the upper version of 3.10. Same thing with Torch and Torch Vision. Finally, configuring the environment and load a pre-trained model. Depending on your task, you might also want to fine-tune SAM2 for specific object tracking needs. If you are working if you are working on a project involving autonomous drones, SAM2 can help your system track objects like trees, obstacles, or even people in real time. Now comes on the limitation of SAM2. While SAM2 is incredibly powerful, it does have some limitations. For example, it may lose track of objects during long sequences or significant viewpoint changes. It can confuse similar looking objects in crowded scene. Its efficiency drops when processing multiple objects at once. Fine details may be missed, especially with fast moving objects. Like example, in a scene when two similar cars pass each other, SAM2 may confuse the two or lose track of one. However, with further input points or fine tuning, this can be integrated. So, I would like to show you another video where you can where I will explore the limitations of SAM2. So it was a video where we are using SAM2 with OpenCV for the live streaming object detection. So here you can see it's tracking the object on real time perfectly. But when I go out from the frame and reappear in the scene, it loses the tracking. So that's the limitation of SAM2. And thus future potentials which SAM2 can show us. Despite these challenges, SAM2 has immense future potential. Its applications range from healthcare to entertainment. As the technology evolves, it will continue to reshape industries that rely on real-time object tracking and segmentation. Think about the possibilities in agriculture or in any industry. SAM2 could help drones track and monitor crops growth or even detect pests in real time. To wrap up, SAM2 present a major leap forward in object segmentation tracking, particularly for video. Its ease of use, flexibility, and wide range of application make it a valuable tool for industries like robotics, healthcare, and entertainment. I encourage you to explore SAM2 further and see how it can benefit your projects. Thank you for attending today's webinar, and I am happy to take any questions now. Anyone have any
Thank
question?
you, Arif. Yeah, Arif.
Yeah, Sumit.
Yeah, first of all, we are grateful that you took the time to acknowledge us about the SAM2 model, as it has many features that we can use in different fields. So
Yes.
how about like if we want to fine tune SAM2 for a specific task or objects? Like you showed it with humans, so how about with some other objects?
Yes, SAM2 is designed to be highly flexible. You can fine-tune the pre-trained model to focus on a specific object or scenario by training it on a custom dataset. So for that, first you need to create a custom dataset. This is especially useful when you have a specialized task, such as tracking particular features in medical imaging or monitoring unique object in a surveillance video. So the range of these thing is unlimited. So through fine tuning, you can enhance the model accuracy for a specific object or environment it will encounter.
Okay, I got the answer. Yeah.
Okay.
Hi, Arif.
Yeah. Hi, Nikita.
Yeah, Arif, it is very good to know that AI has capabilities to uh, track the moving objects. So I have a question: how does SAM2 handle reappear in videos?
Like as I saw you in my video, in my later video, where the object is reappear and it lost you know, it lost the tracking. So it occurs when object is temporarily hidden or observed by another object in a video, or it is, goes out from the scene. SAM2 tackles this by using advanced tracking algorithms such as optical flow and temporal attention. So these are the future potentials. SAM2 can on that SAM2 can enhance its performance. So we are looking forward for it.
Okay.
Any other
Hi Arif.
questions? Yeah. Hi, Ankit.
Uh, I have a question that you shown that it was working with the recorded video, right? The one
Yes.
you showed in the video.
Yes.
So is it can it detect the object in live video streams also?
Like it worked perfectly on the pre-recorded video because it is especially designed for the video segmentation. But we can use it for live streaming, but the performance will be the issue on the live streaming. As I show you my last video where I was trying to live stream, where I was trying to track a object on live stream. So on that, the streaming is not that much good. It was tracking, but it was not tracking on the real time. It was, behind some frames. So it come like it's a currently it's a limitation of SAM2 that it doesn't work that much good on live streaming as compared to video segmentation. So they can enhance the SAM2 performance. The Meta can enhance the SAM2 performance on live streaming. So this could be this could come in future potentials of SAM2. But for the pre-recorded video, it's worked perfectly.
Okay, got it.
Yeah, I think it will be game changing if like Sam 2 can work on the live stream videos also. So another question, Arif, actually.
Yes.
So like what is the time duration of a video that Sam 2 can handle? How like if I have to what is the time limit of the video that I have to provide? Or will it work on any long even on long duration videos?
Like there's no limit uh, for the long duration video, which SAM2 that cannot handle. Like SAM2 is especially designed to handle long duration videos, but memory management can become a challenge if the video length is extreme or if multiple objects are being tracked. The model store temporal information for tracking, so processing extended sequences can lead to higher memory issues. So it depends on your like on your hardware also. So for this it's depend on your hardware, but it can arise a memory issue for the longer video.
So can I use the like virtual computers or do I have to actually buy a physical system?
Like as I tried SAM2 on my local system, so I have a 12 GB GPU, so it was working fine with 12 GB GPU. But if you don't have to run an AI model, obviously you need GPUs. So like if you have that much GPU, so you can try SAM2 on your local system. Otherwise, on cloud also, like some third party clouds like mass compute where you can purchase a cloud for some time on a cheaper price. So on that, you can also try.
Okay, Arif, thanks for the insights. I'll definitely try this.
Okay, Sumit. Any other questions? So I think, guys, you don't have any other question. So let's wrap up this session. And thank you for joining. And if you enjoy like this type of content on the advanced technologies of AI, so please, consider to subscribe our channel. Thank you.